Hello, quarantine sixth graders, and welcome to day 5 of distance learning. Um, just as a heads up, let's see, I've got these two jerks sitting behind me, so I'm sure the orange one, Hobbs, is going to start messing with me any moment now. In fact, he's already hopped down from that little perch and he's already sniffing my keyboard. But that's just the way life goes. On a bit of very good news, you are now starting to catch on to our new routine. Today is day 4. It's Thursday, and this morning around 10 a.m., I got up. I went to check on Wednesday's activity, the one I assigned yesterday, and 94 of you have already done day three's activity in 24 hours. So that is awesome. Monday, I only had like 50 of you do this. So this is a great progress. Thank you for figuring out what you're supposed to do. All right, we are going to be, of course, doing our extensions of our learning. We've been hitting atoms, molecules, compounds, elements, and density pretty hard. And today we're going to kind of wrap up these words. So we now know that a mineral is naturally occurring. It is an inorganic solid and it has a definite chemical composition. Today we're going to be focusing on an orderly arrangement of atoms. That's just a fancy way of saying that it's a crystal. If you think back to the first quarter, there were two types of solids. There were crystalline and amorphous. Crystalline substances, the atoms and molecules are in a repeating pattern throughout the substance. And in an amorphous solid, there is no pattern to the atoms or molecules. And here's a good visual representation of that. Here we have amorphous. So there is no real rhyme or reason. It's a solid because they're all connected and they're not moving except for vibrating in place. They're in fixed positions, but it's very irregular. Over here we have a crystalline solid, very evident pattern to it. So minerals have to be crystalline, not amorphous. It extends in the third dimension as well. Here we can see that we have a repeating pattern and then stacks of repeating patterns in 3D. Sometimes it gets a little bit complicated, but there's still a very evident 3D pattern to the way that the molecules are arranging themselves. That leads us to very cool looking crystals and some boring looking crystals, but I chose a pretty one to put in the picture. Here is a picture of a cave that has the world's largest crystals. Those are people that are climbing around on this. I believe, and I'm very willing to be wrong on this, that this is a cave in Mexico where they grow. But yeah, these crystals are all minerals because they meet all 4 criteria. They are naturally occurring. These do not come from an organism, so they are inorganic. They have a definite chemical composition, and they have a repeating structure. And you can see here, this one along the bottom has a definite shape to it, and that's because a result of its repeating patterns. Minerals can, in those repeating patterns, sometimes have impurities trapped along inside. They're not really part of the crystal structure, but they are kind of trapped along in spaces in between. And that can affect the way that light travels through them and will affect their color. We'll talk about more of this next week, but I just wanted to show you that minerals can come in a lot of different colors because of impurities that are trapped in that repeating crystal structure. So, depending on the chemical composition, every molecule's got its own shape. Atoms will arrange themselves into these repeating patterns, and then that crystal seed will start to repeat that pattern on all of its sides, and so that pattern repeats itself over and over and over again. If you get a crystal mineral that is going to develop slowly and in an open space, you can very easily see the pattern. If the mineral is developed too quickly or in a confined space where it can't grow in the direction that it wants, that pattern will not be apparent. So let's take, for example, the cubic crystal structure. Their crystal minerals come in different crystal shapes, and I think there's 7 or 8 that we have to know in 6th grade. But the basic one is a cube. So each one of these is going to represent either an atom or an entire molecule. This could be an entire molecule here, and that same molecule is here, and that same molecule is there. And they develop themselves into all 90-degree angles, all equally distanced apart from each other. That gives a cube. Then the next set of molecules will begin to build a cube off of this cube. And then more of that atom or molecule will develop and into little cubes that attach themselves to the bigger cube, and you get an even bigger cube made out of smaller cubes. And nature will do this all on its own. One of the things that you'll hear me say is that nature loves patterns, and minerals especially so. So minerals that develop into a cubic structure will actually make giant cubes out of molecular cubes, and you get something that looks like that. So fluorite is a mineral that has a cubic crystal structure. This orange cube here is not been cut. It's not been shaped in any way. It grew naturally into a nearly perfect cube. There's this other substance that it's growing next to, but fluorite right here, as you can see, it grew a perfect cube on its own. Minerals will do this. They have a crystal structure that repeats over and over and over again, and you can just look at it and say, "Oh, fluorite's got a cubic crystal structure." Another crystal structure that we are going to have to know is the hexagonal crystal structure. So the molecules will form a hexagonal ring, and then another hexagonal ring will grow, and then they will become connected to this molecular ring. And then more hexagonal prisms will attach themselves on all the sides, and then on top and bottom in a constant repeating pattern until you get something that looks like that. So again, this hasn't been cut, shaped, or anything like that. It was found like this, and here you can see the hexagon, and that it grew into naturally, and then stacks and stacks and stacks and stacks of hexagons all create this one giant hexagonal prism. Corundum is the mineral from which we get rubies and sapphires. All right. Another one is the tetragonal, very similar to the cubic, but it's just stretched in one dimension. And an example of that would be wolfenite. So here again are perfect, near perfect crystals that have a very distinct shape. And again, this happened naturally without any kind of interference or help or shaping or cutting or anything like that. We have to know 2 ways that minerals can form, or the crystals of minerals can form. They can form from either magma, or they can form from a solution. So magma is molten rock. As magma cools, it's got a very high thermal energy to start off with, so the atoms are very, very active. Well, as it loses thermal energy, the atoms are going to move closer together, and they are also going to slow down. And eventually, when they solidify, they will start forming themselves into patterns, because that's what minerals like to do. They just like making themselves into patterns. If the magma cools slowly, we get very large, regularly shaped crystals, and you can just look at them and say, "Oh yeah, that's that shape." If magma cools too quickly, or lava cools too quickly, we will get very small, irregularly shaped crystals. So if you give minerals time and space, they make very nice crystals. If you give minerals not enough space or not enough time, they make poor crystals. Solution is a word that we've been working with since the first quarter. It is a substance that's been dissolved into a liquid. When a substance is dissolved into a liquid, to get it to form crystals, you have to saturate your mixture. The word saturate means it can't hold anymore. So let's take, for example, you had something like sugar, which is not a mineral. Take sugar, dissolve it into water. Awesome. Now pour in more sugar and stir and dissolve. Awesome. Pour in more sugar, stir, dissolve. Awesome. Keep doing this over and over and over again, and eventually the water just simply can't take on any more sugar. It doesn't matter how much you stir and stir and stir and stir, you're just going to have a snow globe and sugar will not dissolve. You have saturated your solution. When the mineral or when the solution gets saturated, then crystals will start to form. Um, and that's pretty much all we need to do right now. So we're going to pause. Believe it or not, this whole week was just the first part of the introduction to Chapter 3, Lesson 1. Next week will be more of this kind of thing. I'll break it into small little videos. There is no bookwork yet. All right. It'll happen eventually, but for now, no bookwork yet. Bye bye.